All right, Hoover High Intermediate Math 3. This is your assignment 5.03. So here the question is, it's copied and therefore it's hard to read the angles, but that's a 30 degree, that's a 60 degree angle. And the question just says give the coordinates. So you simply come over here. You're not really interested in this angle, you're interested in the central angle. That angle right there is 30 degrees. So you come over here, there's 30 degrees. Really, when it says 30 there, it means that's 30. When this says 45, it means that angle is 45. Okay, so 30 degree angle, these are the coordinates. So if this represents 1, a unit circle represents 1, just call it 1 anything, whatever you want, an inch. That represents 1 inch. Then this distance, down from this point, straight down, and then this distance from that point where it intersected that line right there. You're always dealing with one side being this origin line that says 0. So this is always your starting line when you move around the unit circle. You start from there and you can go around and around and go to certain places. So this is the starting line. So there's one side right there. There's the other side from here to here, not all the way to the end of the circle, but from here to here. So this side is the 1/2. If this is 1, so we'll go ahead and write a 1 there, 1 inch, then this would be a 1/2 inch. And this is the square root of 3 over 2, which is about, square root of 3 over 2 is about 5/6 of an inch. But you don't write that, you write square root of 3 over 2. It's that, and that's that distance from here to here. So the coordinates, if you look at this as a triangle, like you're plotting coordinates from 0 to here like you would in algebra class or geometry class, you go on the x-axis square root of 3 over 2 and you go up 1/2, and that would be those distances. Again, that's assuming that this is 1, this right here. So now you have a triangle here. Okay, so the answer to the question is the coordinates of the 30 degree angle are square root of 3 over 2 and 1/2. Okay, and it says show work. The only thing you could show is that if you use the Pythagorean theorem, let me go ahead and write that. It's a squared plus b squared equals c squared, where c is this side. Well, we said that was 1. So 1 squared is going to be 1, and that's going to be a squared plus b squared is 1/2. We said that, so we're going to square that, and we're going to square that. Okay, and let me move down there. So the square root of 3 squared is 3, and 2 squared is 4, 1 squared is 1, and 2 squared is 4. So 3 plus 1 is 4 over 4, which equals 1. That's what we said it had to equal. Okay, so that's the only work you really would need to show for that. Okay? All right, the next two are exactly the same. This one deals with the 45 degree angle. Again, this angle is not important. It's this angle, the central angle is 45. And the next one is, again, you just go to this circle right here and look them up. This side is 60. That's what you're interested in, not the 30. That's not important. And go ahead and do the same thing for those two. All right, next, tangent. Find the exact value of the trigonometric function. So again, just have this ready. The first thing you're going to do is you want to define what a tangent is. So a tangent is opposite over adjacent. And the other thing is you want to find where this particular measure is. 5 pi over 3. You just come over here and you come all the way around. If it's a pi, it's going to be one of the radian measures. There it is right there. 5 pi over 3 right there. Okay? So there it is. So the coordinates for 5 pi over 3, you can see them here, are 1/2. How did they get that? they moved in this direction 1/2. That's on the positive x direction, 1/2. And they moved down in the negative direction, negative square root of 3 over 2. Okay, so what we can do is we can come over here and draw that triangle. It's actually this triangle up here like that. It's going to be a triangle that looks like that. So let's go ahead and do that over here. So over here we have, and this won't be exactly measured to scale, but it'll be close enough. Over here we have the 1/2, and then you come down, and I'll just say to about there, and then you come up like this. Okay, so again, what is that? That's this triangle where this is the hypotenuse. The hypotenuse is always going to be these lines coming out. That's going to be 1. So this is 1. And then we said that the coordinate says you go positive 1/2 to right about there. And then you have to go down from the x-axis on down. So from here on down to there. This right here, I'll draw it lightly so I don't mess up the circle. That's going to be negative square root of 3 over 2. Okay? And again, the angle here this is what's called a reference angle. So you say, what is this angle? Okay, we're dealing with this line and this line right here. So what's that angle right there? Well, it's going from 360 to 300. That's a difference of 60. So that's a reference angle of 60. It's the angle that's the closest measure to the x-axis. Okay, so this is the x-axis, or on the triangle I drew, this is the x-axis right here. And so that's 60 degrees. You don't worry about positive or negative 60 degrees in this case. It's just 60 degrees because that's what we use to figure out sines and cosines and things, or angles between 0 and 90. All right, so if this is the reference angle, this is the hypotenuse. This is, if you come across over here, this is the opposite. And this is the side next to the reference angle, so that's the adjacent. Adjacent means next to. Hypotenuse is also next to it, but it already has its name. It's called a hypotenuse. And the one directly across is the opposite. Okay, so we said right here that tangent is opposite over adjacent, so that's going to be root 3 over 2 over 1/2. Negative root 3 over 2. So there's the opposite, and there's the adjacent. Okay, now you simply have to remember your fraction math, okay? And what you do is you flip the bottom and multiply. So that's going to equal this. So I flipped the bottom. I took that and I flipped it upside down. Okay, so now you multiply. Multiply means you multiply top across, bottom across. But before you do that, you can cancel. You can cancel anything on the top with anything on the bottom, so that means 2 and 2 will cancel. And so that leaves us with root 3 over 2. Excuse me, root 3. The 2 went away. Over 1 is what I meant to say. And you don't have to write over 1. You could just leave it as that. So that is the answer to this one. Okay? All right, so think about that. The way to learn these is to practice it. Go back and rewrite it and be sure you know the steps and you understand two things. Can you remember the steps, and what do they mean? What does each step mean? Why did I do each step along the way? So what did I do? I basically redrew. I found the 5/3. I made a triangle out of that. One side of the triangle is always this spoke, this line coming out from the center. And then you have an x coordinate and a y coordinate. Okay, and there they are right there. They give them to you on this circle. All right? Then once you have those, you say, okay, you identify which side is which. This is the 1/2 side. This is the negative square root of 2 side. And this is always 1. That's always 1. That's why it's called a unit circle. Unit means 1. Circle. And then you identify what they're looking for. Tangent, opposite over adjacent. So you take the opposite, you put it over the adjacent, and then you just do the fraction math on it and you come up with your final answer, okay? So practice that until you can do it without looking at my answer. That's the only way you'll really know whether you know this. Okay, let's go on and do this one, secant. Okay, right there is secant. So, and there is, it's 7 pi over 6. So let's just come over here and identify 7 pi over 6. Okay, and we come around and around, and again, if it's in pi, it's going to be one of these radian measures on the inside. There it is right there. Okay, so what I'm going to do is, to get to this point, you come along the x-axis here until you get even with this point right here, and then you draw a line straight up and down right there. So what I'm going to do is reproduce that triangle over on my sheet, and I'd like you to always do that as well. So again, it doesn't have to be exactly to scale, but it should be pretty close. It's going to look something like this. Okay, so there's the x-axis part of it. There's this part of it. And then it's going to come down something like this. Okay, and there's this part of it right there. And then there's going to be a line straight up and down there. Like that. Okay, so what's the reference angle? It's this angle right here. Again, it's the closest angle to the x-axis. Okay, so you don't go all the way from here over to there. No, you go here to here. And what's that angle? What's the positive measure of that angle? We're not interested in negative numbers here. Well, 180 to 210. You just do a subtraction, 210 minus 180. Do that on your calculator if you need to, and you get 30. So that means this reference angle here is going to be 30. Okay? And this long side is the hypotenuse, and we said that's always going to equal 1 in a unit circle. So the hypotenuse is 1, and then we get the coordinates. There's the x-coordinate. It's negative because you're starting here and you're going backwards on the x-axis. That's going to be negative root 3 over 2. So that's this. That's the adjacent. Okay, that's the adjacent because it's next to this angle, and then the opposite is this one over here. And so to get from here to here, you went backwards, you went negative on the x-axis, and now you're going to go down. That's negative on the y-axis, and there it is right there. It's negative 1/2. Okay, so there you have all your sides, you have your triangle. Now it's asking for a secant. What is a secant? So you come over here. And a secant is hypotenuse over adjacent, right there. That's where you go to find that. So I'm just going to write that. Okay, so hypotenuse is 1. And adjacent is this one, negative square root of 3 over 2. You can say root 3 over 2 if you hear that. That's what that means. I just want to be sure you're clear what that is. Negative root 3 over 2. Okay, there it is. So you've written the secant of that particular angle. It's 30 degrees, but they're not using degrees, so I should use what they're using. We usually like to think in degrees. It's 7 pi over 6. If this is a unit circle, this is 1. All these radii are 1. Radiuses are 1. This distance right here, radians is a measure of distance on a unit circle. It's 7 pi over 6, which is a little greater than 1. I'm going to say it's about 1.14. It's 1 times pi, which brings it up to about 3. It's 706 pi. It's going to be about 3.5 to 4 inches if we talk about the radius as being in inches. But you don't have to worry about that. But go ahead and write this down since that's what they're talking about. So this is 7 pi over 6. If you want, you can write that equals 30 degrees on a unit circle. Okay? So now just do your fraction math. You flip the bottom and multiply. So it's simply going to be... That's simply going to give you 1. And you can express 1. There's your fraction. And you can express 1 as a fraction by calling it 1 over 1. That's perfectly acceptable. And that's times 2 over negative square root of 3. Again, you can express any whole number as a fraction just by putting a 1 underneath it. So if you feel more comfortable having a fraction and a fraction, that's fine. Go ahead and do that. So it's 2 times 1 equals 2. I'm going to write it down here. And 1 times negative square root of 3 is negative, and it doesn't matter where you put the negative sign, negative square root of 3. Okay, so that's what that looks like. Let me just give that a little more space so it's a little clearer. Doesn't matter where you put the negative sign. Now, rationalize the denominator means you can't have a root like that in the denominator. The square root of 3 is an irrational number. It's 1.71 and then goes on forever, one of those numbers that goes on forever. You're not supposed to have an irrational number in the denominator of a fraction. So how do you get that out of there? You simply multiply. It's just the same way every time you're asked to do this. You take that and you multiply the top and the bottom by that number, by that root. Okay, square root of 3 over square root of 3 equals 1. So 1 times this is just this. Okay, you're just multiplying this by 1. There's nothing illegal about that. Okay, so negative 2 times square root of 3 is this. Over, and square root of 3 times square root of 3 is 3. So now you have a regular integer value, whole number value in the denominator. So that's called rationalizing the denominator, okay? So that's the final answer for this question. All right. Okay, I realized I skipped some problems, so I will go back and do those, okay? I started with 7. I didn't do 4, 5, and 6. I will do those, okay? Let's go ahead and just continue since I'm on this page. I didn't notice that I'd taken that page out and set it aside. So I'll go back and do that one. Okay, I'll finish those at the end. I'll get to 4, 5, and 6 at the end. Okay, here we go. Cosecant. So 2 things you got to do. You got to identify where 5 pi over 4 is, and identify the reference angle. And then cosecant what that is. Okay, let's do that first. This time it doesn't matter what order. Cosecant equals, so you come over here, and cosecant is hypotenuse over opposite. Hypotenuse over opposite. So we're just going to write that. Okay. All right. So let's go ahead and find 5 pi over 4. So we come over here. Again, it's going to be a radian measure here, and there it is right there. It's that one right there. All right, so the reference angle there is, it's going from 180 to 225. So just what's the difference between those two numbers on your calculator? Again, you always want a positive angle. And if you do that on your calculator, 225 minus 180, you get 45. It's 45 degrees. Okay. Of course, it doesn't really matter. You're given the coordinates here anyway. You don't really have to do any calculations of sines and cosines on your calculator for this particular assignment. So what we're going to do is draw, here's the end of our triangle. There's the hypotenuse. And so we're going to draw a line from here back to right about there. And from there straight down to there. So there's our triangle. I'm tracing out the triangle that we're going to draw. It just so happens, as you'll learn, a 45-degree angle in any direction, these two sides are going to be the same. The length of that side and the length of that side are going to be the same. This side is still the hypotenuse. It's going to be 1. All of these lines from the center of the circle are 1. Okay, so let's draw that triangle over here. So it's going, here's the center of the circle right there, and we're going to go here to, I don't know, right about here maybe. Again, we're not trying to draw this exactly to scale. And then we're going to go from here down to here, and then we're going to come down like this. Okay, so that is this triangle from here to here, from here down to here, and then that diagonal is the hypotenuse right there. Okay, so here's the hypotenuse, the longest side. Okay, and the coordinates are going to be negative because you're going to start here, you're going to go negative on the x-axis, that's backwards to the left, and then you're going to go down on the y-axis, that's negative on the y-axis. And here are the coordinates right here. And we just said those two sides are the same length. There they are. It's negative square root of 2 over 2. So we'll come over here. Here's the reference angle. Let's use this proper because it's really, they're using radians here. Okay, so this is the adjacent. And opposite is all the way across. And hypotenuse is there. So this side is negative square root of 2 over 2, and this side is negative square root of 2 over 2. All right, so what are they asking for? The cosecant is hypotenuse over opposite. It's this over this one. We don't really care about this one in this particular problem. So that's going to equal 1 over. And now you're going to flip the bottom and multiply. Again, you can turn that into a fraction if you want to have a fraction. So 1 over 1, that's the fraction form of that. Times, you don't have to do that. And you flip this one. Okay, nothing cancels here, so it's 1 times 2 is 2. And 1 times negative root 2, and you can put the negative sign anywhere you want, top, bottom, in the middle. Usually put it in the middle, and that's going to be root 2. Okay, again, you have to rationalize the denominator. You do it the same way we did above, so that's going to be times square root of 2 over square root of 2. Okay, so negative 2 times root 2 gives you negative 2 root 2. And square root of 2 times square root of 2 gives you 2. Right there. So that's exactly what we did above, except this time you got one more step. You can cancel the 2's. The 2 over the 2 cancels, so your final answer is going to be negative square root of 2. That is your final answer. Okay. So again, go back and redo this on just a blank piece of paper, not even one you're going to turn in, and see if you can do it from memory. Again, let's review the steps. First, you had to identify what a cosecant was. It's hypotenuse over opposite. Next, you had to identify where 5 pi over 4 is on this. Then draw that triangle. Here are the coordinates that they're talking about. This is the x-coordinate, the first one, negative root 2 over 2. And the y-coordinate going down is the second one, negative root 2 over 2. And the hypotenuse is always 1. So this was asking for hypotenuse over this one, negative root 2 over 2. And after that, it's just fraction math. So be sure you know the fraction math to do this. All right, let's move on to number 10. Notice something, I'm doing them all for you, except 2 and 3 I didn't do for you because they're really easy. So I hope you don't find those to be hard. Okay, cotangent. Let's define what it is. Cotangent. So cotangent is right here, and it's the reciprocal of the tangent, so it's adjacent over opposite. Adjacent over opposite right there. Okay, that's cotangent. Okay, next thing we're going to do is find pi over 4. So we come over to our unit circle and look for radians, and there it is right there. It's at 45 degrees, okay? So the triangle you're going to form to this point out here is going to come straight down to the x-axis and this way. So this way and this way, like that. So we're going to draw that triangle. And there's the angle. And again, it's a 45-degree angle, but they reference it in radians, so we could call it pi over 4. And pi over 4 is really a distance. It's the distance around this curve from here to here if this is a radius of 1. Pi over 4 is roughly 3/4. Roughly 3/4 of pi. So that's you know, I don't know, about 2.5 inches or something like that, if you wanted to think of it in inches. All right, I mean, you can do it on your calculator, but you don't need to. Okay, but that's what a radian measure is. It's a distance. But we refer to it on a unit circle as an angle there because it's always going to be the same distance if it's a unit circle. Okay, and then we need the coordinates. There they are, square root of 2 over 2, square root of 2 over 2. You notice it's the same as the ones we used over here, except these were negatives. So that's why this is called a 45-degree reference angle. This is a 45-degree reference angle. These are both positive. You go positive on the x-axis, and then you go up positive on the y-axis. So those are both positive numbers. So that's going to equal adjacent. Let's write it over here first. This is the hypotenuse. That equals 1. This is the angle, so on the opposite side of the angle is going to be square root of 2 over 2, that's positive, and on the adjacent is square root of 2 over 2. Okay, so what we're looking for here is adjacent over opposite, this over this, so that's going to look like this. Square root of 2. That's a 2. Okay, so square root of 2 over 2 over square root of 2 over 2. For some of you, this might be obvious that anything, even something that's a fraction like this, over itself is going to equal 1. But if that's not obvious to you, let's just do it the proper way. You take the top, you rewrite it, times the bottom flipped over. So that's going to be 2 over the square root of 2. So the 2's cancel, square root of 2 cancels. When you cancel them, it's not 0, they don't go away, it's just 1, they become 1's. So you have all 1's, 1 times 1 times 1 times 1 on the bottom, and you get 1. Okay, so that was a much easier one. That's your answer. It's 1. Okay, and that's all there is to it. All right. Let me go back and do 4, 5, and 6 now. So 4, we do every class. It says label coordinates and angle measures in radians and degrees of all points in the unit circle. So we do that every class. That's why I wrote the word done there. Okay, so if you do that in class, we didn't do it the last class, but we did it the classes before. And that's how you do that, okay? In which quadrants is the sign positive? Okay, so first of all, let's define sine. And now while they spell out the full word S-I-N-E, when you write it in math, you always write it like this. And what is sine? Sine equals, it equals opposite over hypotenuse. Okay, now the hypotenuse is always a positive number. It's always 1, no matter which direction it's going in. This, it's always a positive number. But the sines and cosines aren't. You notice that the adjacents and opposites in this quadrant called quadrant 1, that's the starting quadrant, because remember the starting line for your unit circles here. On your mark, get set, go, and you start running this way. So these are all positive numbers. You'll notice they're all positive numbers. When you come over here, the x-coordinate, you're going backwards, so that's a negative number, and then you go up for any of these numbers. So the x-coordinate, this first number is going to be negative, the second number is going to be positive. That's the second quadrant, by the way. When you get down into the third quadrant, there it is, quadrant 3. We worked in this quadrant. You notice that they're negative, negative. You're going negative on the x-axis, and then down is negative on the y-axis. So it's negative, negative, negative. Okay. When you come over here, you're going to go positive on the x-axis to get over here, and down, that's negative on the y-axis. So the first number is positive, the second number is negative. Okay, so they're asking about the sine. Sine is opposite over hypotenuse. Okay, so since hypotenuse always equals a positive 1, then the opposite, they want to know in which is it positive. It's where is the opposite going to be positive? Where is that going to be a plus number? So we look up here, and right over here, let's just take this triangle that we already used. The opposite is this side, and you can see it's a positive 1/2 because you're going up. Any of these angles here, you're going positive. Positive. So the opposite is always going to be positive in quadrant 1. So the answer to that is quadrant 1. And which else? Now the next one's a little trickier. Well, no, it's not. I take that back. The next problem's a little trickier. If you come over here, now we get past here, now we come over here. The opposites, you'll notice the second number, that is going from here up here, is also positive. So the opposites are positive in this quadrant as well. So that's quadrant 2. So we'll put 1. Let's do it in Roman numerals the way they do it. 2. What about here? The opposite is this one right here. And those are negative. You'll notice those are all negatives over there. Okay, not a 0, but this one, negative. It's going down. So the sign would not be opposite over hypotenuse. Again, opposite is negative. Hypotenuse is always a positive 1. So that would be negative over positive in quadrant 3. That's not positive for sine. Finally, over here, the opposite is going down. Again, we did this triangle right here, and it's going down. So the opposite is that second number right there. It's this side right here. That's negative over positive 1 is also negative. So the sine opposite over hypotenuse is not going to be positive. So the answer is quad 1 and 2. The sine is positive. That's your final answer. 1 and 2. Okay, that's these two up here, because you're always going up, and that's the sine is the opposite, and the opposite is always going up in the positive direction in those two quadrants, 1 and 2. Okay, next one. Tangent. This one's a little harder. Tangent. In what quadrants is tangent negative? Okay, so first let's define tangent. Tangent is, come over here if you don't remember it, is opposite over adjacent. All right, so come over here. So remember, the opposite of all these angles is going to be the up and down one. The second coordinate is the opposite in all the way around the circle. Over here, it's going down. All right, so if it's going to be negative, then either you have a positive opposite over a negative adjacent. That would be a negative tangent. Or you have a negative opposite over a positive adjacent. So one of them has to be not exactly, one of them has to be negative. If they were both negative, negative over negative is a positive. That would be a positive tangent. So one of them is positive and one of them is negative. So let's come over here and find out where that happens. Well, everything along here is positive. Everything's positive there. When you come over to quadrant 2, you see that the first one is negative and the second one is positive. First one negative, second positive, first negative, second positive. So quadrant 2, if you put one of these over the other, that would be the tangent. It would be the opposite, the second one, over the adjacent, the first one. That would be a negative tangent. So the answer here is quadrant 2. Okay, now you come down here and you see negative, 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 negative. So if you put one of these over the other, the negatives would cancel out and become a positive. So all of these would have a positive tangent. Now it seems kind of weird, but their negative over a negative is going to be a positive. Okay, negative 4 divided by negative 2 is positive 2. All right, so that would give you a positive. You come over here and you have a positive for the adjacent, the first one, and a negative for the opposite, the second one. Positive adjacent, negative opposite. So this is positive negative, so that means you're going to have a negative tangent in quadrant 4. So it's 2 and 4. And that the V is a 5 minus a 1. That's how you write Roman numerals if you've never experienced that before. So that, let me just write it in normal numbers. This is a 2 and this is a 4. It's just traditionally they're written in Roman numerals. Okay? The answer is have negative tangent. Okay, and that's the answer to that. All right, so that takes care of it. The only ones I didn't do are 2 and 3, which are easy if you've seen number 1, and that's it. Okay, sorry these got up a little late. I've been having some issues at my home with the electrical system. It's been a mess. Anyway, get these done. This assignment is, you saw how quickly I did it. But be sure you know how to do the problems as well. Just practice them once or twice until you feel you can do the problem without looking at the video. Okay? Anyway, we'll see you in class.